For our first lesson, it's all about empirical and molecular formula. The objectives of this lesson, you will know what is empirical and molecular formula. You will learn how to calculate the empirical and molecular formula, and also to solve problem solving involving empirical and molecular formula. But before we start, what is empirical and molecular formula? Molecular formulas tell you how many atoms of each elements are in a compound, and empirical formula tell you the simplest or most reduced ratio of elements in a compound. It is a compound's molecular formula cannot be reduced by any more than the empirical formula is the same as the molecular formula. So, for our first example, our given is a compound is composed of 52.12% of carbon, 13.13% hydrogen, and 34.73% oxygen by mass. A. What is the empirical formula? And B. If the molar mass of the compound is 138.204 grams per mole, what is the molecular formula?
The first step to find the empirical formula is step 1. List all the given. And the givens are 52.14 grams of carbon and 13.13 grams of hydrogen and 34.73 grams of oxygen. And then step 2, you need to convert it into moles. 52.14 grams over 1 times 1 mole of carbon over the atomic weight of carbon. And the atomic weight is 12.01 grams. Then 13.13 grams of hydrogen over 1 times 1 mole of hydrogen over the atomic weight of hydrogen is 1.008 grams of hydrogen. And then the oxygen is 34.73 grams of oxygen over 1 times 1 mole of oxygen over the atomic weight of oxygen is 16 grams of oxygen. Then you need to divide it and cancel it. And if you calculate it on the calculator, the answer are 4.34 mole, 13.026 mole, and 2.171 mole. And then step 3 is you need to divide all the given by the smallest of the 3 values. And 2.171 divided by 2.171 divided by 2.171. Then if you calculate it on the calculator, it is equals to 2, 6, and 1. So our empirical formula is C2H6O1. So now we have to find the molar mass of the empirical formula. The molar mass of the compound is 138.204. The first step is copy the given. The given is 2C plus 6H plus 1 oxygen. The empirical is like this. H6. Then the second step is multiply the given by its molar weight or atomic weight. So 2 times 6. The carbon of molar weight is 12.01 plus 6 times atomic weight of hydrogen is 1.008 plus 1 times the number of oxygen, 6 equals to 16. So if we add all of them, the answer will be 46.068. So now, the third step, we will divide the 46.068 by 138.204. 46.08 over 138.204, and if we calculate it on the calculator, the answer will be 3. So now, the fourth step, we need to multiply the subscript, the empirical formula, by 3. 3 times carbon 2 is equals to C6, or carbon 6. 3 times 6 hydrogen is equals to hydrogen 18. And lastly, 3 times oxygen 1 is equals to oxygen 2. So now this is the empirical formula. The molar mass of the compound is 138.204.
So for now, our topic is all about percentage of composition. But first, what is percentage of composition? Percent composition tells you by the mass what percent of element is present in a compound. A chemical compound is a combination of 2 or more elements. If you are studying a chemical compound, you may want to find the percent composition.
Now, for our first example, C12H22O11. To find the percentage, you need to multiply the given by its atomic weight. Now, 12 times its atomic weight, which is 12.01, plus 22, 1.008, plus 11, the atomic weight of oxygen, which is 16. Now, add all of it, then the result is 342.96 grams or mole. Now, for our second step, you need to multiply the given by its atomic weight, then divide it by the answer from step 1. Then multiply it by 100%. So, carbon is equals to 12 times its atomic weight by 12.01 over the total of step 1 is 342.96. Then multiply it by 100%. Then the answer is 42.1%. Then hydrogen is equals to 22 times its atomic weight, which is 1.008 over the result from step 1 is 342.96 times 100% is equals to 6.5%. Now for oxygen, is equals to 11 times its atomic weight, which is 16, over the result from step 1, which is 342.96 times 100% is equals to 51.4%. Then third step, you need to add all of the answers from step 2 and the result must be 100%. Now add all of this, yeah, and the result is 100%, which is correct.
Okay, for our second example, we will have C5, H9, and O2. Okay, for the first step, we will multiply them to their own atomic mass, which is 5C plus 9H plus N plus 2 oxygen. Okay, for the second step, we will get the atomic mass and multiply it. 5, 12.01 plus 9, 1.008 plus 14.01 plus 2, 16. Okay? The answer will be 60.05 plus 9.072 plus 14.01 plus 32. And the total of the given will be 115.132 grams of mole. The third step, it will be, we will multiply each of these from our first given. So it will be percent carbon equals 60.05 over 115.132. Then, we will multiply it to 100%. 100% equals 52.16%. And we will just rewrite it here. So it will be percent hydrogen equals 9.072 over 115.132 times 100% equals 7.88%. So, for the third, it will be percent N equals 14.01 over 115.32 times 100% equals, the total is 12.17%. And for the last one, it will be percent oxygen equals 32 over 115.132 times 100% equals 27.79%. And if we total it, we will get a total of 100%. So that means it's correct. And also, for our third and last lesson, it's all about mole of the concept. The mole is an amount unit similar to familiar units like fair. For example, dozen, gross, etc. It provides a specific measure of numbers of atoms or molecules in a bulk sample of matter. A mole is defined as the amount of substance containing the same number of discrete entities like atoms, molecules, ions, etc.
For our second example, how many molecules are there in 4.0 moles of carbon dioxide? 1 mole is equals to 6.02 times 10 to the power of 22 according to Avogadro's number. First, we need to convert moles to molecules. Our given is 4.0 moles of carbon dioxide. Then, we multiply it by Avogadro's number, which is 6.02 times 10 raised to the 23rd molecules of carbon dioxide over 1 mole of CO2. Then we cancel out the common units. Then multiply 4.0 by 6.02, then the answer is 24.08, and if you round off, the answer is 24.1. So, next step, we need to put decimal point to the left once. So, our answer is 2.41 times 10 to the power of 23. Molecules of CO2. or carbon dioxide.